Okay, welcome to Chapter 6. We got a lot to cover, so let's get on it. The title of this lesson is Angles of Polygons. So we have a polygon right here. Let's make it just a little bit bigger so we can see it. And what I'm going to do first of all is talk about one particular word, and that word is diagonal. And let's write it in here. You've probably used that word many times before, but in geometry, this is what a diagonal is. A diagonal of a polygon, anyway. Diagonal of a polygon. You start at any vertex. It doesn't matter which vertex you start at. Let's just start right here up top. And a diagonal, it's a line segment, or it's a line segment that connects any two non-consecutive vertices. What does that mean? Well, what's a consecutive vertex? It would mean one right next to each other. So this one right here would be a consecutive vertex, and so would this one. Oops, ran out of my screen here. And so would that one right there. Right there. Here we go. That would be consecutive. What would non-consecutive be? Non-consecutive would be way down here like this. All right, it's the one that's not right next to each other. This point is right next to this one. This point, see, they're right next to each other. If I went around the horn, as they say, if I went from here to here, that would be consecutive vertex. This is a non-consecutive vertex. So what is a diagonal? A diagonal, is a line segment that connects non-consecutive vertices. So that would be one. Let's start at that. Let's go back to that same exact point where we started. Let's go to another vertex, and that would be right here. And let's go from that same vertex where we started, and let's go to another non-consecutive vertex. So those would be non-consecutive vertices. So each one of these red lines right here is considered to be a diagonal. All right, you say, well, what's the big deal with that? Well, what's nice about this is this is going to help us find what the sum of the angles of any polygon is actually going to be. So, for instance, if I wanted to find this polygon, how many sides does this polygon have? 1, 2, 3, 4, 5, 6. So it's a six-sided polygon. These diagonals are going to help me find the sum of the angles of a six-sided polygon or of a hexagon. But let's go back in time a little bit and talk just about a single triangle. So here I have a single triangle, and what I'm going to do is, this is kind of like a process. What I'm going to do is try to come up with a little formula that we're going to use. I could sit here and just give you the formula. You're probably thinking, just give it to me, just tell me how to do it. But I want you to understand why and where this thing comes from. So let's go back and talk about the diagonals again. What I want to do is, can I draw any diagonals in a three-sided polygon? A three-sided polygon is a triangle, obviously. Can I draw a diagonal on a triangle? Well, let's think about it. Where do I have to start? You can start at any vertex, and I have to go to a non-consecutive vertex. But there's a problem with that. If I go here, okay, that would be consecutive. That would be consecutive. Are there any other vertices I can draw to? No, there's not. So can I draw any diagonals in one triangle? No, I can't. And you say, well, okay, big deal. Well, what I want to do is take a look at this. I am trying to find, my eventual goal right here is to find the sum of the interior angles of a polygon. All right, this is just a start of what we're going to do. This is a really important start. I want to show you why we're doing what we're doing, not just tell you how to do it, okay? So I want to find the sum of the interior angles of a polygon. Well, I already know this. I learned this in the other chapter on the sum of the interior angles of a triangle. If I took this angle and this one, and if I added them all three together, this is angle 1, angle 2, and angle 3. If I added angle 1, angle 2, and angle 3 together, what would the sum be? It'd be 180 degrees. So if I have one triangle, I have 0 diagonals, by the way, which gives me one triangle, and one triangle is going to be 1 times 180. Now, the reason I put the 1 there is because I have one triangle. What if we had 2 triangles? It would be 2 times 180. What if I had 3 triangles? It'd be 3 times 180. And I'm getting somewhere with this, okay? So just hold on tight. Now I have a 4-sided figure. I had 3 sides up here, so let me write that. If I have 3 sides, I have one triangle, and 1 times 180 is 180 degrees. This time I have 4 sides. Let's write that down. And you'll see a little pattern developing here. We'll do about 2 or 3 of these. Okay, so if I have 4 sides, I want to find out how many triangles am I going to get. Well, what does that mean? Well, what I have to do is have to draw a diagonal. Up here, I couldn't draw a diagonal, so there was just the one triangle. But right here, I can draw a diagonal, and only one diagonal. If you look at it, I can't go to here. Where do I go? I go here, and I can't go anywhere else. So that would be the only diagonal that I can draw. So how many triangles do I have in this picture? Well, I've got one triangle right here. Do you see that? Okay, and then I've got a second triangle right in here. So I've got two triangles. So 4 sides gives me 2 triangles. And if I wanted to find the sum of the interior angles of this polygon, and if I wanted to add up this angle plus this one plus this one plus this one, if I wanted to add up those 4 angles, what would they add up to be? Well, this is one triangle, which is 180. This is another triangle, which is 180. So it would be 2 triangles, each one being 180 degrees, and what would that give you? That would give you 360 degrees. So it doesn't matter how I drew this, okay? There was nothing magical about how I drew that 4-sided figure, that quadrilateral. I get 2 triangles out of it if I draw all the diagonals that I can draw. So if I have 2 triangles, it's 2 times 180, and 2 times 180 is 360. So what is the sum of all the interior angles of this polygon? If I added up all 4 angles, I would get 360 degrees. It doesn't matter what the quadrilateral looks like. If it's 4 sides and if it's a polygon, and actually I should throw this in there, it needs to be a convex polygon, okay? I should have put that right in front of polygon. All right, if it's a convex polygon, we got to make sure we say that, then if you add up all 4 angles, you're going to get 360 degrees. All right, what if you had 5 sides? Well, I'm glad you asked, because let's take a look at one with 5 sides. Okay, here's a 5-sided polygon. Let's write that down. So if we have 5 sides, again, I'm trying to establish a pattern here. That's all I'm trying to do. If I have 5 sides, how many triangles can I get out of this thing? Well, let's pick a vertex and draw all the diagonals I can possibly draw from that one particular vertex. So let's go to here and let's go to here. It's all the triangles that I can draw. It's all the diagonals I can draw, and that's all the triangles I get. So how many triangles do I get here? I get 1, 2, 3. So if I have 5 sides, I have 3 triangles. And if I wanted to find, again, the sum, that's what, remember it was on that other screen, if I want to do the sum of all the angles of this polygon, I take the 3 triangles and I go 3 times 180, and that, I believe, is 540 degrees. So anytime you have a 5-sided figure, it doesn't matter with the shape, it's got to be convex, so it does kind of matter. But as long as I have a 5-sided convex polygon, all the angles, if I add up this angle and this one and this one and this one and this one, if I add up those 5 angles, I will always get 540 degrees. Okay, here's the last one we're going to do, and we're going to do the same thing. Pick a vertex, any vertex, I don't care. Sound like a magician or something. Pick a card, any card. Let's pick this vertex right here. It doesn't matter which one you pick. Let's go from here and let's draw all the diagonals that I could possibly draw. There's 1, there's 2, and there are 3. So I want to find out how many triangles I have in this thing. 1, 2, 3, 4. Hopefully you see a pattern developing here. How many sides did I have? I have 6 sides. That's a hexagon. By the way, that one up top was a pentagon. I don't think I said that. So if I have 6 sides, that's going to give me 4 triangles. And how do I find out the sum of all the interior angles of this convex polygon? I take 4 and times 180, and that's going to give me 720 degrees. And so if I add it up, if I have a 6-sided figure, if I add up all 6 of those angles, it doesn't matter the shape of this thing at all. As long as it's a convex polygon, if I added up the interior angles of this convex polygon, I'm going to get 720 degrees. Let's go back up here and see if we can develop a little pattern. All right, here's what I want you to look at. If we have 3 sides, how many triangles do we have? 1 triangle. If I have 4 sides, how many triangles? 2. So this is what I'm doing. How did I get from 3 to 1, from 4 to 2? Let's keep sliding down. From 5 to 3, right? 5 sides, 3 triangles. And then the last one we did, we had 6 sides and we had 4 triangles. What did we do in all 3 of those situations? All right? 3 to 1, 4 to 2, 5 to 3, and 6 to 4. Well, hopefully it's a pretty simple process that we did. We just subtracted 2. So we took the number of sides. Let's do that. The number of Squeezed it in a little too tight. The number of sides, and what did we do to find out how many triangles there were? We subtracted 2 from it. So I took the number of sides minus 2. Now, what did I eventually do to find the angles in this, all the interior angles? I multiplied it by 180. Now, instead of writing this mess right here, the number of sides, what they do is they use the letter n to represent the number of sides. All right, so if you have 6 sides, then n is equal to 6. Should have put it right there. Okay, n would be 6 because that's 6 sides. The one with 5 sides, n would be 5, and so on. So n represents the number of sides. So what is our little formula then for the sum of the interior angles of a convex polygon? I'll write convex this time. Can't forget that. Because if it's concave, it's different. We're only going to deal with convex, though. All right, so here's our formula. The sum of the interior angles of a convex polygon is n minus 2. Right? Why n? Because that's the number of sides minus 2. Why 2? Because we went through that whole process and we saw we had 2 less triangles than we have number of sides. So it's n minus 2 times 180. And that's really a super important little formula that we just came up with right there. All right, we kind of came up with it on our own. Now, it took me 11 minutes to get to it, but I think that was 11 minutes well spent because it's important, I think, that you see how we came up with this little formula. So you take the number of sides you have minus 2 times 180. So let's do a quick example right here. Let's say we had a polygon. Let's go crazy. Let's go 17 sides. So if we had a polygon with 17 sides, now I don't have to draw the thing out because I made up a little formula. So instead of drawing it out, counting it up, drawing all the diagonals, finding out how many triangles we have, instead of going through that mess, we can just say, if there's 17 sides, how many triangles are there going to be? Well, there's going to be 17 minus 2 triangles. And each triangle is 180 degrees, so I take 15 and multiply it by 180 degrees. And that's going to give you the sum of the angles inside of a polygon, a convex polygon with 17 sides. I don't know what that is off the top of my head. So let's see what that is. It's 15 times 180. Oops, let's go back one. 180, there we go. And that's 2,700 degrees. So that means if I drew a polygon with 17 sides, and all the sides don't have to be equal or anything like that, okay? It's just a convex polygon with 17 sides. If I add it up, remember, this is the sum of the angles. If I added up the sum of the interior angles of a 17-sided polygon, this is how I would do it. I just take 2 away from 17, multiply it by 180, and then you stick it in a calculator. It's 2,700 degrees. Doesn't mean each angle is 2,700 degrees, obviously. It just means that if you add up all 17 angles, right, because if there's 17 sides, there's 17 angles, then you're going to get 2,700 degrees. Okay, now I'm on the Geogebra program, and I thought I would just do a couple examples just to kind of show you what's going to happen here. Let's do a polygon. Let's do like, kind of make it small. It's 1, 2, let's see, 3, 4, 5. We'll go pentagon. Okay, so there's a pentagon. And what we want to do is we want to find out what all the angles add up to be. And there's a little process that I'm going to go through. I'm going to pause it here for a second, but I'm going to go through this process and show you what each of these angles actually are. Okay, what I did right here was I let Geogebra, I just selected these angles and they told me what the angles are. Now, I have to preface this. It might not come out exactly right because these numbers are rounded. I just made just any kind of polygon, and they actually rounded, so they actually found the real degrees here. Okay, these are not made up values, they're actually real degrees, but they're rounded to the nearest unit place, okay, to the nearest ones place. So it might be off just a little bit, and I've already done the math on it. It is off like one number, but it'll show you that it's pretty close. So what do we have here? We got 1, 2, 3, 4, 5. We have 5 sides right here. So how would I find the sum of the angles of a 5-sided figure? So let's do that over here. Let's jump back to this. So this time I have 5 sides. So how would I figure that out? Well, you go 5 minus 2 times 180. Well, 5 minus 2 is easy. That's 3 times 180. and that should be 540 degrees. All right, so let's go back to GeoGebra, and these angles should add up to 540 degrees. Well, here's my math that I did on the calculator. Let's turn it on. And I added them all up, but there's a little problem. It came out to 539. And the only reason for that is because it rounded, okay, and it didn't round it up. So looks like I'm a liar, but really it is true. It would be 500. Let's see, did I do that right? Yeah, 540 degrees, right? Just because of the rounding, that's why it's off a little bit. What's cool about this program is this. Okay, this is why I wanted to show you this program. Watch this. I could change the look of this. See, I made that 95 a little different. I made that a little different. I don't know if I can. Yeah, I can. I can drag all these. See, I'm not changing how many sides this thing has. I'm just changing the shape of it. Let's see if I can even do that. All right, mess around with it a little bit like that. So check this out. Now, they're different values. I don't know if I changed all of them or not, but they are different values. And so let's plug that into a calculator and see what I get. So I just took these angles right here, I added them together, and I stuck them in the calculator, and there it is right there. It comes out to 539 again, because of the rounding, right? It actually figured out what they really are, and that's why it's not 540. It should be 540 technically, but you get the idea. I hope that doesn't bother you too much with the rounding part. All right, I think that's pretty cool. That it's a great way to show you that no matter what the shape, I could have changed the shape of it. It still had 5 sides. It's still convex. Now watch what happens if I do this. If I make it concave, look what happens. Look at this angle right here. This interior angle is still an angle, but it's actually more than 180. It's 235. Now if I added them all together, it's going to be way more than 540, all right, depending on how big I make that angle and that kind of thing. So it doesn't work with a concave, but it does work as long as I go like this, okay, as long as this is more than 100, or actually be less than 180 right there, then it's going to work out just fine. All right, I hope that helps you understand that a little bit better. Now what we're going to do is talk about another type of polygon, and that would be a regular polygon. A regular polygon, I don't know if I've talked about a regular polygon or not, but let's talk about it now. It's not that hard to figure out. A regular polygon has 2 things that are true about it. Let me do it like this. All the angles in a regular polygon are equal to each other, and all the sides of a regular polygon are equal to each other. So if I have a polygon that's called regular, and we're going to use this quite a bit, all right? So if it's a regular polygon, all the angles are equal to each other. They're all exactly the same, and all the sides are exactly the same as well. We've talked about that actually before, and that would be like an equilateral triangle. Equilateral triangle is also equiangular, and we figured out how many degrees on an equiangular triangle. Remember, they add up to 180. If all 3 are exactly the same, we went 180 divided by 3, and we got 60 degrees. So we have done that before. But now we're going to go beyond a triangle. We're going to go 4, 5, 6, 7, and even more sides of a regular polygon. Let's just use a simple one, and this is a pentagon. So let's go to pentagon, and let's try to figure out, we're not going to just find the sum of all the angles. We already know how to do that, okay? It's 5 minus 2, which is 3, times 180, which is 540. So all 5 of these angles add up to be 540 degrees. So we already know that. We know the sum of the angles is equal to 540 degrees. That's what we just finished talking about. But now, since this is regular, all the sides are equals, all the sides are equal, and all the angles are equal to each other. So we have a regular pentagon. This is a regular pentagon, which means, now the real important thing here is that all the angles are equal to each other. All right, so every one of these angles are equal. So we want to find the measure of each. Make sure that you read the problem carefully, because sometimes they'll say find the sum of the measures, and sometimes they'll say find the measure of each angle. If they say find each, you're just finding one of them, not all 5 of them, just one of them. All right, so we know that the sum of the angles is 540. So let's think about this. If all of these angles, all 5 of these angles add up to 540 degrees. And if every single one of these angles are equal to each other, then how are we going to find out what each one is worth? Well, that's simple. We just divide it by how many angles we have. And we have 5 angles. Notice, if we have 5 angles, we also have 5 sides. So I could also say divide it by the number of sides if I wanted to. But it makes sense. 5 angles, they all add up to 540. So let's do the math on that and figure out what that is. So it's 540 divided by 5, and that gives us 108 degrees. So each angle is, let's put it right here, each angle is 108 degrees. So that's 108. I don't have to do it every single time. I know that every single one of these is 108 degrees because it's a regular polygon, which means all the angles are equal and all the sides are equal. Now, that doesn't help you tell how long the sides are, but it definitely tells you how big the angles are. So that's how you can find each angle. That's the key. Each angle in a regular polygon. Okay, we're back to GeoGebra. What I decided to do is make a pentagon just like we did before. And just to show you that, I didn't show you how I drew all this on GeoGebra, but it tells you right here exactly what these angles are. Notice, it tells you they're 108 degrees. Now, we figured it out without knowing any numbers except for the number of sides, and it's regular. So every single one of these angles is 108. What's kind of cool about this program is that I could change the size of this by grabbing this point, and watch, I can make it smaller, but does that change the value of the angles? Look, the sides change. Remember what they were before? I think they were 8 before. And look, as I make it smaller, the sides are now 3, but look what happens to the angles. They don't change at all. Okay, as long as it stays regular, as long as all the sides are equal to each other, then let's make it even like the 10, okay? You can see that. As long as the angles are equal to each other, or I'm sorry, as long as it's a regular polygon, the sides definitely change, but the angles stay exactly the same, okay? It doesn't matter how big or how small it is, the angles stay exactly the same. Okay, here's a problem that's a little bit trickier than just saying, okay, if you have so many sides, what's each interior angle? That's not actually that hard, okay? We did it with a pentagon. You can do it with any size figure or polygon, but this one's a little tougher. It says the measure of an interior angle of a regular polygon is 135 degrees. So let's think about this. I'm not going to draw the whole polygon because I don't know how many sides there are, so I don't know exactly how to draw it, but you do know that the measure is 135 degrees. So we'll just kind of estimate it right here. This, you don't have to do this, but sometimes it's helpful. So this angle is 135 degrees, and you've got these other sides going around. I got to figure out how many sides are in this polygon. If this is a regular polygon and all the sides are equal, all the angles are equal, how many sides are in this? Now remember we said before, the number of angles in a polygon is the same as the number of sides. So we could just find out how many angles we have, and that's the same as the number of sides. But let's use a formula that we're kind of familiar with at this point. It says, now they tell you an interior angle, but we do have a formula for the sum of the interior angles. So I'll just put sum. Let's do the whole thing. The sum of the interior angles. And what is that formula? Well, it's n, whoops, make that look a little nicer, n minus 2 times 180. Remember what the n stands for. It's how many sides you have. So we actually need to solve for n. But let's figure out this. Do we know what the sum of the interior angles actually is? Well, we know one of them. This is not 135. We know one of the angles is 135, but we don't know how many sides. Let's just say, I don't know, let's just make a guess. So let's say it's not 5, but let's say that there was 5 sides, okay? So to find out the sum of all the interior angles, we would take each angle and multiply it by 5. You know it's not 5 because we just did one and it was 108 degrees. But what would we have to do? This is the part that's a little tricky, so bear with me. It's 135 times how many angles you have. I think that makes sense, doesn't it? The sum of the interior angles is 135 times n, because one angle is 135. Depending on how many angles you have, you would multiply 135 times how many angles you have, and that would give you the sum of the interior angles. I think that makes pretty good sense. And so now what we're going to do is we're going to solve for n. Well, I would distribute the 180 through here, so you'd get 180n minus 2 times 180, which is 360. And now we go ahead and we solve 4n. So let's do the math real quick. So we subtract 135n from both sides to put it over here, and let's get the 360 on both sides. So we add the 360 to both sides. Of course, that cancels out. I've added the 360, and what do you get for this? That's 5. That's 45. Is that right? 45n. That canceled out. And to get n, you divide by 45. Divide that by 45, and let's see what that is. It's, turn it on, there we go. It's 360 divided by 45, and that gives you 8. So n equals 8. What does that mean? That means there are 8 angles, which means that there are 8 sides. So this is an 8-sided figure. An 8-sided figure is called an octagon, all right? And that's what it would be. And now if it was a polygon, or if it's a regular polygon, it's a regular octagon, and we see regular octagons all the time. What would a regular octagon be? That's right, it's a stop sign. Okay, that's a regular polygon. You see one of these probably every day. It's a regular polygon. It's 8 sides. So what would the angle right here be? If you wanted to go up to a stop sign, take your protractor out and measure it. I could save you the trouble. It would be 135 degrees. So this is the angle of a stop sign, which is kind of interesting. All right, let's try to go through this kind of quick. What we're going to talk about now is an exterior angle. We've talked about exterior angles before, but we have one more theorem to deal with, and it's about the exterior angles and not the interior. These inside would be the interior. And you're like, well, I don't see any exterior. Well, to get an exterior, what you're going to have to do is you're going to have to take one of the sides and extend it out. So we take that side, extend it out. We'll take that side, extend it, and we'll take this side and extend it. I'm just going to tell you what this theorem says, and this is pretty interesting. This angle right here, we'll call that, I don't know, we'll call that angle A. This exterior, see this outer one right here? We'll call this one B, this one right here, and we'll call this one C, this one right here. These are exterior angles that are formed by this triangle. This theorem says, and this is a really nice theorem, because it says that the exterior angles will always equal 360 degrees. It does not matter how many sides you have. The exterior angles to any convex polygon, it doesn't matter how many sides, it's always going to be 360 degrees, which is really, really nice thing to know. Okay, I made this figure 1, 2, 3, 4, 5 sides, and I extended all the sides. See, this one right here, extends here, and so forth. And I marked all the exterior angles. These angles are all the exterior angles to this polygon right here. See, this one right here would be an interior angle, so would this one, and this one, this one, this one, but these are exterior angles. Also, notice something about the exterior angle compared to the interior angle. Let's see if I can do this. Oops, I got the wrong button. Let's see if I can do it here. That's not exactly what I wanted, but that's okay. If I wanted to figure out what the angle right next to it would be, I'd go 180 minus 67, right? And that would be the interior angle. But I'm looking at the exteriors, and if I add them all up, which I've already done on my calculator, just trust me on that. There we go. I added up all the angles, and I get 360 degrees. Now, I actually have different numbers than I have here because I think I scooched this thing around a little bit. This should have been 110, and I think I messed it up a little bit, but you get the idea. My original angles, I think I got it right now, 67, 49. Yeah, there it goes. So they all add up to 60 degrees, and it doesn't matter how you shape this thing out. If you take this and make it like that, see what happens? That got smaller, but that got bigger. All right. You could go like this. See what happened right there? That got bigger and that got smaller. It compensates. They all compensate for each other. Watch this one. As this one right here, let's see what it's doing. It's getting bigger. What's happening to that? It's getting smaller incrementally. So Doesn't matter how you shape this thing out. Try it yourself. Try those numbers right here. They're different numbers. Add them up. They'll always add up to 360 degrees, which is really nice because it's really easy. You don't have to do anything complicated. You know that they're 360. Here's another key that you're going to have to use. Remember, the interior, this one right here, and the exterior are supplementary. So if I wanted to find this interior angle, I could go 180 minus 68, and I've got this angle right here. So that should help you out a little bit. Okay, I'm going to finish up this lesson with this last example. It says find the measure of each interior, okay, not the sum, but each interior angle of a regular decagon. Deca is 10, excuse me, it's 10. So it's a 10-sided polygon. There's two ways to do this. I'm going to show you both ways, and you can pick which way you like the best. Let's do it the way with the first not definition, but the first formula that I gave you with that n minus 2 times 180. We want to find the measure of each interior angle of a regular, okay, all the angles are equal to each other, decagon. So you could do this. You could find the sum first. Find the sum of all the angles first, which is what? It's n minus 2 times 180. Now that gives you all the angles added up. So it's a decagon. So it's 10 minus 2 times 180. 10 minus 2 is 8, and 8 times 180. I should know that off the top of my head, but I don't. So let's see. It's 8 times 180, and that gives you 1440. Oops, a little crooked there. So that's 1440. Now that's not my answer. Okay, that's the sum of all the angles. But remember, all the angles are exactly the same. And how many angles are there? Well, it's a decagon, so there's 10 angles. So I'm going to take that 1440 divided by 10, because there's 10 angles and they're all exactly the same, so I could divide them evenly by 10, and I get 144 degrees. So that's a nice, easy way to do it. Well, there's another way I could do this also. I could use the exterior angles. Now let me just draw a little diagram. You don't have to draw this diagram to be able to get this problem right. I just think it's kind of helpful. Now remember, this would be an interior. We're trying to find that angle right there if we have 10 sides. But what I'm going to do is I'm going to actually use the exterior angle theorem. Remember what's true about the interior and the exterior. They're supplements of each other. So I can actually find the exterior angle, and then all I got to do is take that away from 180, and I've got this. Watch how easy it is to find the exterior angle. Remember, all the exterior angles add up to 360 degrees. Well, how many exterior angles are there? There's just as many as there are interior angles. It's a decagon, so there's 10. So each exterior angle is just 36 degrees. So this angle right here is 36 degrees. It's not my answer. This right here is my answer, this angle right there. But what's true about these two angles? They are supplementary. So really, all I have to do is 180 minus 36, do the math, and look what you get. You get 144. I don't know about you. I like the math a little bit better on this problem, or this way of doing it, than this way right here. Either way, you get the same answer. It doesn't really make any difference how you do it. I just think sometimes going with the exterior angle is a little bit better. Well, sorry this went over 30 minutes. I really tried to keep this short, but there was no nonsense. We went right to it, and I think it helps you out. Hopefully this helps you out a little bit. There's a lot of information in here, so hopefully it helps you out. So good luck on this lesson.